So the last topic in this section is related to the Earth and maps of the Earth. So the Earth is a big sphere out in space, and I haven't used Google Maps in a long time. I turned it on today, and it's evolved a lot since I've used it last. I can kind of rotate it through space right here. It's kind of neat. So apparently the sun's out that way behind me in the upper left somewhere. So here's this great big floating ball we live on. Not insane. We live on this big ball spinning and rotating through space. All right, so here's North America right there, North America. And here's Greenland over there. So since humans have existed, they've been drawing maps of their towns, of their cities, of their states, of their countries and continents. And this becomes a little bit tricky because maps are on paper, but we live on a big ball. Now, if you take a small enough section off of a ball, it'll sit relatively flat if you put it on the table. Right? So imagine you take a balloon and you cut out, you can blow up the balloon, right? It's this nice ballish kind of thing, and you deflate it and you cut a section out of it, and it's going to sit relatively flat if it's small enough. And, what is small enough? Well, I live in a city, and if I looked at the map of my city, if I cut that off of the globe and tried to sit that on the table, it would sit pretty darn flat. And even a bigger area like Eastern Oregon would sit relatively flat if I cut it off the globe. But the map of the whole our Earth is a bit troublesome, and so we've struggled to do that over time. So I just wanted to show some cute maps out there. So one of the first maps of the Earth was the Mercator Map. And I remember seeing these in school. I remember my grandpa had some up on the wall. And this is what's called a cylindrical mapping. And if you look at the book, they'll show what it means to be a cylindrical mapping. But it's just imagine that you wrap the Earth in a cylinder so that the cylinder is tall as the Earth is tall. And then you just try to project the positions of things on Earth onto that cylinder that's surrounding the Earth. And then you unroll that cylinder and you get a flat map. Now, the problem when you do that is some weird stuff happens at the equators, it's not the equators, the poles, the top and bottom. So you get some weird stuff happening up here. Look at how big Greenland looks, bigger than Africa. And there's a note here that 14 Greenland should be able to fit in Africa. So something's wrong with this picture. And look at the size of Antarctica down here. And if we look at Google Maps, and let's see, there's Greenland right there. You can see the size of Greenland. You can see the size here of, say, North America. Greenland is a fraction of North America here, maybe, I'm not sure how much of a fraction. It looks to be on the map here about the size of Central America, maybe not. But if we flip it and look down here at Antarctica, which is kind of hard to see because it's covered in clouds. I wonder if I can remove that cloud layer. Google, will you let me? I should have played with Google Maps more. Ooh, what did I do? Whoa. Is it going to where the Earth is facing now, toward the sun? I guess so. Interesting. Okay, now what I wanted. I was hoping to see Greenland. Not Greenland, Antarctica. So Antarctica is hidden in here. And if you kind of look at the size of that thing right there compared to the map here, right, that's a little bit too big. So some people tried to remedy that. So here is a remedy, the Robinson Compromise map, where they take a slightly different take on how to make the poles a little bit more realistic, or near the poles a little bit more realistic in size. And it's an improvement, but it's not quite the same. There's lots of other kinds of maps, and I think this one is a wicked cool one. So you might have heard of a guy named Buckminster Fuller, or things like Bucky Domes. So he did a lot of interesting 3D geometry. So this map right here is related to basically taking the Earth and imagining, instead of being a sphere, imagine that it is instead an icosahedron. So this shape right here, 20 triangles. So if we traced on top of the globe 20 triangles, and then cut it out with those triangles and then laid them flat, those triangles would be not very flat, but they'd be flat-ish. And we could lay them out. So there's going to be a lot less distortion in this map right here, and you can show things a little better at their different scales. And we can choose to draw the triangles in such a way that we can grab the continents, which is usually what most people are interested in, land areas as opposed to sea areas. But those triangles can be drawn in any orientation you want and then cut out and placed down on the map. So that's a pretty cool map, I thought. And there's just tons of other ways to do it. So I'll put the link to this website here. It's a map company. I am not in any way advertising for this map company. I just thought they did a great job of displaying some of the more popular maps of history and today of the Earth, with some pros and cons about what's cool about this map right here or what are its drawbacks. So I'm going to stop there. Map of the Earth. How do we take a sphere and make a flat map out of it? Small areas, not too much distortion, like Idaho, Rhode Island, a city, no big whoop. But when you try to do whole continents, then you run into some problems like the original cylindrical projection here. All right, that's it for this section. Next, we move on to symmetry in the next week. Have a good day, do good math. Bye-bye.